Hello, good day. My name is Victor. So, welcome to LFS tutorial. Today we'll be having equilibrium of bodies in fluid. And majorly we'll be talking about Archimedes principle, and then we'll talk about Upthrust, and then we'll explain what Archimedes principle is all about. And then from there we'll take a look at some likely jam pass questions, some jam pass questions, and some likely jam questions on Archimedes principle and equilibrium of bodies in fluid. Let's start. Archimedes principle states that when the body is partially or wholly immersed in a fluid, it means when the body it is completely immersed in a fluid or it is partially immersed in a fluid, it experiences an upthrust. So when the body is completely or wholly immersed in a fluid, is completely or partially immersed in a fluid, it experiences an upthrust. An upthrust which is equal to the weight of the fluid displaced. An upthrust which is equal to the weight of the fluid displaced, So what's Archimedes trying to tell us? He's trying to say that anytime a body is immersed in a fluid, the body experiences an upthrust. An upthrust means loss in weight. It means the body becomes light. Let's take a look at example. I don't know whether you fetched water before. I remember I've fetched water before, and anytime I move closer to the well and I put my fetcher inside the well, when the fetcher is still inside the well, the fetcher becomes light as long as it's inside the well. But if you make any attempt to draw the water out of the well, you discover that it becomes heavy. So anytime a body is inside a fluid, let's say we have a container like this and it is completely immersed in water. We have a body which is completely immersed in water. And then we have water all over this body like this. And then once this body is completely immersed in water, it becomes light. So even if I attach a rope to this body and there's someone holding this rope here, and if the person holding this rope here will discover that this body is light, because initially if this body, weight of this body is measured with the aid of a spring balance, the weight is measured with the aid of a spring balance, I'll have the weight in air, WA. Let's say you can have something like 10 Newton or you can have something like 12 Newton. The weight, once it is measured with the aid of a spring balance. Now, if this weight now is, this body now is now immersed in a fluid, it becomes light. The weight will not be equal to 10 Newton again. We have something less than 10 Newton. Let's say something like 6 Newton. So we discover that there's a loss in weight when the body is immersed in water. So Archimedes is trying to say when the body is completely immersed in a fluid or partially immersed in a fluid, it experiences an upthrust. An upthrust is a loss in weight. And what is actually an upthrust? An upthrust is an upward force exerted by the water at the base of the object. It's immersed in the water. So it's an upthrust force exerted by this water on the bottom of this object. And upthrust is an upward force. And this is it is normal, logical. If you think it, if I have a particular box and then I attach it with a rope to it and then I'm dropping it down, even if I'm not putting it inside the water, just holding it, you know, if there's someone that is holding the base of the box that you are holding with a rope, it becomes light, because more of the weight you will not feel it again. It becomes light. So it's also the same thing. While the object is inside the water, there's an upward force exerted by the water on the object, and this upward force is called upthrust, so that you won't feel much of the weight while it's in water. And the weight of the object always outward, downward. So we see upthrust and weight, they are acting in opposite direction, and there's a tension on this rope. So from here we see that the tension on this rope, or the weight, the reading of this spring balance is equal to what? Weight minus upthrust. Just like vector, they are traveling in opposite direction. Remember that the weight will be higher, the weight in air, and the upthrust will be lost in weight, and then we have something like this. And then from here we can see that our upthrust is equal to weight minus tension. That is the first formula that we have for upthrust. Upthrust is equal to weight minus tension. Don't forget that this is the weight in air. When we have a spring balance, something like this, and we have the weight being measured, the weight in air. So if we put the same object again in the water and we attach again to a spring balance, so we have the same weight measured, but it is now less than the first one that we have, and that's the weight in fluid for upthrust. Now let's take a look at the second case. Another way we can calculate upthrust is equal to weight in air minus weight in fluid or weight in liquid. Weight in air minus weight in liquid. Let's say the weight in air is 10 Newton, and then while this thing is inside water, I record the weight again. Let's say the weight is like, let's say something like 6 Newton. So the upthrust will now become weight in air minus weight in liquid. So there are two ways of, the first way of getting upthrust, you say weight minus tension, or you say weight in air minus weight in liquid. Don't forget that the weight in liquid is the tension on this rope that we have here. The weight in liquid is the tension on this rope. And the third formula that we can also apply to solve any question under upthrust is that, remember that the question says the principle says it expresses an upthrust which is equal to the weight of the fluid displaced. Upthrust is also equal to weight of the fluid displaced. Weight of the fluid displaced. Upthrust is not equal to the weight of the fluid here, but the weight of the fluid displaced. So you see that so far now we've discussed three formulas that you can use to calculate upthrust. Number one, you can use weight minus tension. Number two, you can use weight in air minus weight in fluid. Number three, weight upthrust is equal to weight of the fluid displaced. Let me explain the third one. Upthrust is not equal to the weight of the fluid, but equal to weight of the fluid displaced. Let's say we have an American, and then the American is filled with water, let's say at 4 centimeters. And then we have a body immersed in this water, fully immersed in this water. Initially, the volume of this water is 4 centimeters cube at this point, 4 centimeters cube. Now, when you now immerse a body inside this water, you know that the level will increase from 4 centimeters cube, let's say, to 7 centimeters cube. So the level of the water would have increased, let's say, from 4 centimeters cube to what? To 7 centimeters cube. Now, the difference in volume, 7 minus 4 is what? 3 centimeters cube. So the weight of the 3 centimeters cube is equal. So the difference in the volume of the increase in volume is 7 minus 4, which is equal to what? 3 centimeters cube. So the weight of this liquid displaced is equal to upthrust. So if you measure 3 centimeters cube on a scale, what is the weight of it? It will give you what? It is equivalent to what? Upthrust. Or other means of solving this is if you have an Eureka can, and then water is filled to this place, and then you put a particular solid inside this Eureka can, you know that it is logical to think that the water will pour inside another beaker at this point. Let's say at this point we have 4 centimeters cube of water, and then by the time you put a mass inside this beaker, then another water will pour here. Let's say the water that is poured here is now what? 3 centimeters cube. By the time you measure this water on a scale, it will be equivalent to what? Upthrust. So upthrust is equal to weight in air minus weight in fluid. Upthrust is equal to weight minus tension, and upthrust is equal to weight of the liquid displaced. Let's take a look at the first example. Okay, let's take a look at the first example. A block of material of volume 2 times 10 raised by minus 5 meter cube. So the volume of the object that we have here is 2 times 10 raised by minus 5 meter cube, and the density of the object is 2.5 times 10 raised by 3 kilogram per meter cube. It's suspended from a spring balance, and then when there's a spring balance, and then this object is suspended from a spring balance with half the volume of the block immersed in water. So this is the block is immersed in water, but it's only half of it that is immersed in water. So don't forget that the volume of the object is what? 2 times 10 to the minus 5 meter cube. The density of the object is 2.5 times 10 to the 3 kilogram per meter cube, and then it is suspended from a spring balance with half the volume of the object, half of this volume of the object immersed in water. And then they're asking me what is the reading of the spring balance. What is the reading of the spring balance? Remember that we said the other time that this spring balance is going to record the tension on this rope. It's going to record the tension on this rope. I will say the upthrust is an upward force acting like this, while the weight will act downward. So the tension is equal to what? Weight minus upthrust. Tension is equal to weight minus upthrust. The first thing is to calculate the weight. We have to calculate the weight. Calculate the weight. Remember that weight is equal to mg. W equal to what? Mass times gravity. So what is the mass of the object? We are going to look for that one. Multiply by what? Acceleration due to gravity. Since density is equal to mass over volume, so that means the mass of the object is equal to what? Density of the object multiplied by what? Volume of the object. So the weight is equal to what? Let's replace the mass of the object with density of the object multiplied by volume of the object. That will be density of the object multiplied by volume of the object multiplied by g. So what is density of the object? The density of the object is 2.5 times 10 raised to power 3. 2.5 times 10 raised to power 3 multiplied by what is volume of the object? Volume of the object is 2 multiplied by 10 raised to power minus 5 multiplied by, then what is acceleration due to gravity here is 10. So our answer becomes weight of the object is equal to 2.5 multiplied by 2. You give me 5 times 10 raised to power 3 multiplied by 10 raised to power 1 multiplied by 10 raised to power minus 5. So my weight is equal to 5 times 10 raised to power 3 plus 1, 4. 4 minus 5, that's 10 raised to power minus 1. So that means my weight is equal to what? 0.5 Newton. So this is the weight of the object, 0.5 Newton. Then the next thing is we are going to calculate the upthrust. Calculate the upthrust. Remember that we talked about 3 formula for calculating upthrust. So we are going to use the last one here. That upthrust is equal to weight of the liquid displaced. Upthrust is equal to weight of the liquid displaced. So I'll have upthrust to be equal to weight of the liquid displaced. You are going to ask me a question: why not the first formula? Why the third? Now, if you want to use the first formula that I gave us the other time, that upthrust is equal to weight minus tension, can we use this formula to find upthrust? No. How did I know? The upthrust that we are looking for is unknown. Even the tension is, the reading on the spring balance is unknown. So we have 2 unknown values. We can't use this one. And then the next formula for upthrust is upthrust is equal to what? Weight in air minus weight in liquid. Although we know the weight in air, which is 0.5 Newton, but it's weight in the liquid when it is immersed in water. Did they tell us the weight in liquid? No. And that is the reading on the balance. It is not given, so we can't use this formula. And then the last third formula is upthrust is equal to what? Weight of the liquid displaced. So probably this is where we can get our value of upthrust. Then upthrust is equal to, since weight is equal to mg, since weight is equal to mg, then upthrust is equal to what? Mass of the liquid displaced multiplied by g. Mass of the liquid displaced multiply, not mass of the liquid here, but mass of the liquid displaced. Since density is equal to mass over volume, so that means mass is equal to what? Density times volume. Mass is equal to density times volume. So definitely my upthrust is equal to density of the liquid displaced multiplied by volume of the liquid displaced, and then multiplied by what? Multiplied by g. So let's go back to the question. The liquid that we have here, in which this body is a mass, is water, and the density of water is what? 1.0 times 10 raised to power 3 kilogram per meter cube. Upthrust is equal to 1.0 times 10 raised to power 3 kilogram per meter cube multiplied by the volume of the liquid displaced multiplied by the acceleration to gravity 10. And the question is, what is the volume of the liquid displaced? Now let's analyze this question carefully. When the body is immersed in the liquid, we want to know the volume of the liquid displaced. The volume of the liquid displaced is equal to the volume of the object immersed in water. What am I trying to say? Imagine that I have a stone which has an irregular shape, and then they are asking me to find the volume of the stone which has an irregular shape. Do you know if the object has a regular shape, like the shape of a cuboid, I can use volume equal to length and breadth times height to know the volume of that cuboid. Or if it is a shape of a cube, I can use L raised to power 3, L times L times L, to know the volume of that shape, because it has a regular shape. But if you have an object that has irregular shape and we are asked to find the volume of that object that has irregular shape, the first thing we are going to do is we are going to look for a liquid in which if you put that object, it will not dissolve. Let's say for instance we want to find the volume of a stone, a big stone. We don't know the form, we don't know it doesn't have a regular shape, it's irregular, and we want to find the volume. What we are going to look for a liquid that does not dissolve the stone, probably water. So I will look for a beaker, a million or gravitate cylinder. I will pour enough water into it, and then I will gently I'll pour enough water into it, and then I will note the volume of the water initially, let's say 2 centimeter cube, and then I will gently lower the stone inside this beaker, and then you know that the level of the water will increase, let's say something like 6 centimeter cube. Now the increase in volume, 6 minus 2, 4. So the volume of the liquid displaced, which is 4 centimeter cube, is equivalent to the volume of the stone that I just put inside this water. So it means that the volume of the object is equal to volume of the liquid displaced, as long as the liquid will not dissolve the object. So the volume of the object is equal to volume of the liquid displaced. So what we have here, we are looking at the volume of the liquid displaced. Don't forget that the volume of the liquid displaced is approximately equal to the volume of the object. So what is the volume of the object that we have here? 2 times 10 raised power minus 5 meter cube. But the question says it is only half of the volume of the block that is immersed. So if half of the volume of the block that is immersed, so the level of water that will be displaced upward will be half of the volume of the block. So the volume of the liquid that will be displaced upward will be half of the volume of the block, and that is half of 2.5 times 10 to the minus 5, and divided by 2 give me what? 1 times 10 raised power minus 5. 1 times 10 raised power minus 5. So if I multiply this, so I will have upthrust is equal to 10 raised power 4 multiplied by what? 10 raised power minus 5. And if I do that, upthrust is equal to what? 10 raised power minus 1. Then my upthrust is equal to what? 0.1 Newton. So since we know our weight to be 0.5 Newton and our upthrust to be 0.1 Newton, then tension is equal to weight minus what? Upthrust. That is 0.5 Newton minus what? 0.1 Newton. And then our tension is equal to what? 0.4 Newton. That means by the time we lower this body so that it is half inside this water, the spring balance is going to record a value which is equal to the tension on this rope, and the value is what? 0.4 Newton. 0.4 Newton. Thank you very much for joining us today. You're welcome to LFS tutorial. So we urge you to subscribe to our channel for more videos is coming on physics, chemistry, biology, and then we'll drop your questions so you can try that, and then you see a link into our WhatsApp group. So you can participate. It's free. It's just free. You can participate and then join our online classes. If you have any question, you can drop in the comment section, and then we'll always don't forget, make sure you subscribe, press your notification button, and then like the video, share it. It is very necessary. Thank you very much. This is LFS. Let's keep on finding the S. Bye.